let's do some guided practice for the limits that we just learned. First off, if we have a limit of x approaching anything of a constant, well, that's just going to be the constant itself. There's nothing to plug x into. All right, we're done. Next order of business, in this situation, this is just a straightforward one because we can just plug in 5 and we get 5/14. No problem. Here's where we need to bust out a little bit of technique, right? Here's where we have a situation where if we plug in x equals 1, what's going to happen? Well, it looks like we're going to get 0 in the top and 0 in the bottom. So remember, I like to write 0 over 0 in parentheses to let us know that we have an indeterminate form. So at this point, we would say, okay, this is the same thing as the limit as x approaches 1 of, well, I guess we can factor out an x. And here, well, we can't factor out an x, but I guess we can factor out an x plus 2, x minus 1, and I think that's looking pretty good because that will cancel out in the numerator and denominator, and at this point, we're just going to have 1 over 1 plus 2, which is 1/3. That's our answer. Number 4 is a similar deal. You might notice if we plug in, well, actually, we don't get 0 over 0, do we? But we do get 16 over 0. Now, remember, this is a situation where we're going to have an infinite limit, a non-existent limit, but we just need to take the left and right-hand limits. So we say, okay, left hand, the limit as x approaches 4 from the left, 4x over 2x minus 8 is going to equal, well, let's see, the top is going to be positive. I write a little positive sign right there. And the bottom, well, if we're a little less than 4, that's going to be negative. So it looks like we're going to have a negative, and we're going to infinity, so we have that. Right hand, probably going to be the opposite. Not always going to be the opposite. But in this case, it will be the opposite, right? We have a positive over positive. All right. So our double-sided limit does not exist because the left and right-hand limits are not equal to each other. And I'm going to that's a little different. This is what's called a piecewise function. Now let's see what happens as x approaches -1. Well, it's not totally... We can plug in -1, but that just tells us that g of -1 equals 4. That's not what we're... Let me just write that down so I can cross it out. I'm going to write that down so I can cross it out. That's not relevant to the question we're asking. What we want to do instead is we want to plug in -1 into the left and right-hand parts, right? Limit as x approaches -1 of g of x. We're not sure what that equals, so let's look at the left and right-hand limits. Limit as x approaches -1 from the left of g of x equals the limit as x approaches -1 from the left of 2x plus 7, because that is what is defined when x is less than 1. So that's what the graph is doing when x is less than 1. Okay? So at this point, we can plug in -1, and I think we get 5. We do the same thing, but we plug in -1 into the positive part of the graph, which is this guy. And we get this guy. And at this point, we can plug in -1, and we get 4. Okay? So since 5 does not equal 4, limit as x approaches -1 of g of x does not exist. All right, that's all we got.